Okay, I think we're having so many people joining us now. So without wasting much of our time, I'll go through okay. So good day, everybody, from wherever you're joining us from all over the world. We're really grateful to have you here. Thank you so much. We really appreciate your presence, and we hope you would be fulfilled at the end of the day. So we're going to quickly go through the agenda for today's webinar. So today's webinar is going to be based on geospatial visualization in R. That's geospatial visualization in R. Okay. Okay. So we're starting on time. So we're going to have like 2 minutes to admit and our participants, so those who have registered for the program. So then we're going to introduce the organizers, and we'll introduce our speaker, then we'll allow our speaker to take the floor right away. So right now, we're having the participants coming in. So I'll go ahead to introduce myself as one of the organizers here. So I'm Bilikisu Adenito. I'm a business data analyst based here in Abuja, Nigeria. So I'm an R user, and I'm the founder and co-organizer of Abuja R User Group and R is Abuja. So I've also in the house, Abubakar is a co-organizer of the program. So he's going to be helping with the quick questions and answer. So he's already joined us. So we have so many people that help with the group. We really appreciate their efforts, and they've really supported us so much. So, but unfortunately, we can't go into all the names for now. So that is that for the organizers. So now I'm going to go ahead and introduce our speaker tonight. So please just give me some minutes to admit people. Okay, so I think, okay, so I'll be admitting people at the end of the introduction of our speaker. So right now, I have the honor and privilege to bring onto the webinar tonight, Rami Krispin. He's a data scientist. He's the data manager who mainly focuses on time series analysis and forecasting applications. Is the author of hands-on time series analysis with R and several R packages, including the T-Studio package for time series analysis and forecasting applications. Since the beginning of COVID-19 outbreak, he has been contributing to COVID-19 open source projects, creating several packages such as coronavirus, COVID-19 Italy, 19 SF, and so many more. In the outbreak, I came to know Rami based on all these projects, and I've learned a lot. I've been following on his GitHub page. I've learned a lot. And one thing that really strikes me is that the patience and the response that he gives when you send in a question on the platform that's on the GitHub page, he responds almost immediately. And even if he doesn't get the answer, he still waits on. And anytime I respond back, it takes me through each line one by one. That, okay, now run the first line, no, that was awesome. That was somebody that really touched my heart. And that's a teacher, the quality of a teacher, and really somebody that I really look up to. Is a gentleman to the core. So I felt I learned a lot in the little time that I spent with him, that no, I need to bring him onto our webinar. Although I was kind of skeptical is a big man. That's the term we use in our country here. But he's a big professional based on his status. But it's so down to earth. Immediately I talked to him on LinkedIn. He was so graciously ready to be on our webinar, and I really appreciate that. And I'm so honored to have you here. Thank you so much for honoring me and honoring the group here. We're a small community here, but we really appreciate your presence here. Thank you so much. So, okay, let me take in the people that are already waiting there. Okay, so thank you so much. I really appreciate this. And I'm looking so much to getting to learn so much from you. And I believe everyone here would really learn a lot tonight. Thank you so much. So I'll give you the floor now. I'll take out my sharing. I hope you're ready.
Yes. Okay. Thank you so much. Thank you so much for the invite.
Thank you.
All right. So let me share my screen.
So you can go ahead and share your screen.
Oh yeah, so apparently this is the first time I installed today on this machine Zoom, and it asked me for permission, so I might have to drop and join again. So just give me a second, try to unlock the permission to share screen. So, okay. So I will have to drop and join again. So give me just a second.
No problem. Thank you.
All right, so I hope it will work now. All right, so everyone can see my screen?
Yes, yes, we can see it.
Okay, so I think we can kick it off. So thank you everyone for joining. As mentioned before, we discussed about having some workshop about geospatial visualization with R. I would just say that I'm not expert for geospatial. It's not my main domain area, but it's kind of like a hobby. Hopefully to give you the kickoff, if you don't have a background, I assume that most attendees here have some knowledge in R, but don't have some deep knowledge in GIS analysis. So prepare to give some kind of like the context how to work with the data and how to create visualization. And from there, the sky is the limit. All right, one more thing. I hope that my internet here might be a bit finicky. So if I'm having some issues, so ping me. I will drop my video and I'll just speak. So without further ado, let's kick it off. So the agenda for today is to give just a brief background about what is a geospatial visualization, talk about the objects that we're going to use, talk about data manipulation of GIS objects. We'll play a little bit with merging. We work mainly with the SF objects. Show you how to merge geometric data with some Excel data that you want to visualize, and we build some corporate maps. And I know if you have any question, I typically have our time to track the chat, but if there is any question, so you can feel free to stop me and I can answer them while we are going, and also leave some time at the end to question if there are any. So a little bit about me. So you mentioned already, I'm data science manager. I am mainly focusing on time series analysis and forecasting. That's kind of like my main domain. But today we're going to talk about my hobby, which is more creating maps. I would just say that I know the basics. There might be some stuff that I won't be able to answer, so I can follow up. But I think for the foundation, I have a decent knowledge. I'm using mainly R. I'm open source contributor. I built some packages mentioned before, and you can get in touch with me on LinkedIn, Twitter, and GitHub. I will share at the end those slides and the repository. I'm trying to, let's see if it refreshes to have those slides. Yep. So why don't I will share it with everyone in the chat. If I will figure out how to go back to the chat. I apologize, my Zoom skills are very poor. How do I get back to the chat? Oh, here is the chat. So I shared the link for the slides, and you can also cover them over there. All right, so let's kick it off. So the scope today is to give you some introduction for spatial data, how to work. We were going to work mainly with SF objects, how to visualize those objects with mainly 3 packages: MapView, Tmap, and Gpro2, and we'll see some different core flat maps. And the packages we're going to use today is for the GIS data. We have the R Natural Earth package, which is provide access for the Natural Earth API, which is technically provided a lot of geometric data for different countries and zones in around basically all the countries around the world. It's a public domain and anyone can access it, but the great thing about the Natural Earth that it's kind of like make it much more easier. So you don't need to be expert in GIS analysis to access the data. And I think that's kind of like it reduced the barriers for people that are not from this domain, and you don't need to be some geographic expert. SF package is a great package that define class for this type of data. There are other packages, but again, for simplicity, I decided to use this package. We'll talk more about what are the advantages of this package. And for tools for plotting, MapView is a great tool. Unfortunately, I couldn't render it with this type of slide. This is the first time that I'm trying to do with R Markdown slides. Usually I'm using Keynote, but I can show you more examples on the vignettes that I share a link. You can go, it's interactive. So MapView is a wrapper over the JavaScript leaflet package. And there are other wrappers for this JavaScript library, but this I found like more intuitive to work with. Another great package is the TMAP, which is Thematic Maps. It's a short for Thematic Maps, and it's based on Ggplot 2, if I'm not mistaken. And again, it's a great package for visualization. There is option also to create interactive visualization with a leaflet, like the map view. Last but not least is the Ggplot 2, which is probably all of you familiar. Also enable you to create maps working with SF objects. All of those three are built to work with SF objects, and it makes the work much more easier. The previous is a package for simply to get color palettes. We will use it as well. Data sets. So we're going to use some COVID-19 data from the coronavirus package, cases, and vaccine data. Also, I didn't mention it over here, but we're going to use also data from, since we're in Nigeria, I thought it would be nice to get also data from Nigeria. So I pulled from Wikipedia the population of Nigeria by states, and we're going to plot it as well. So let's talk about the geometry of the objects. So it starts with the point. So if you can think about it, a point in a 2-dimension, it's a pair of data points that each one represents a dimension. So in this case, it's X and Y, and you place it in some space. And the next one is a line, which is a combination of multiple points that create the line. Again, we're talking about 2-dimension, but it could be like more complex visualization of 3 dimensions, for example, but like the focus of this topic is on 2-dimension. And this leads us to polygon, which is a combination of lines that that eventually close the kind of like the, you're starting from one point, moving to a different point, and the end you are ending and you're connecting to the first point. And all the visualization that we're going to focus today based on polygons. And those polygons, this is a simple polygon with 4 points, but as you add more pairs of X and Y, essentially you create a shape like this. And this is the map of Nigeria. And you can see this could be hundreds of, if not thousands of pairs of X and Y, in this case in longitude and latitude points that eventually create this shape, geographic shape. So polygon is going to be the main data that we're going to work with. And it's very useful. This is what we're going to pull from the R Natural Earth package. So if you take those polygons with some levels, you create some boundaries. So this is the map of Earth. As you can see, all those are represented by different polygons. And when we attach them, you're creating this map. And essentially, there is no data here beside the borders. Once you add also data to this, you create a choropleth map, which also give you some inference between different regions. There was any question? All right. So in this case, this is the population in Nigeria by states, and it's the color represent the magnitude of the population. It's going for with a gradient scale. The lowest is state, the smallest state is 2 million. The biggest state, Kanu, I hope I pronounced it correctly, is 16 million. At least at the time that it was the data was collected, 2016. So this is a great way to visualize, to express some comparison between different geographic locations with the use of some color scale or palette. So now let's go to talk about the R natural earth package. So as mentioned before, this is a great resource to pull GIS data from the natural earth API, and I have it open over here. So this is the where you can pull the data, and this is a public domain, and our natural earth package just provide you a link that you can pull the data with. It's a very straightforward to pull the data. So we'll start with the first function, any underscore countries, which provide you access to countries level JS. I'm not sure if there is question. Okay. So in this example, we will load the R natural earth package, and we pulled all the geographic locations in Earth, all the countries. We'll use a small scale, and we use the retain class as SF object. You can also use SP object, but for simplicity, SP object is similar to SF, but the structure is a bit different, and it's a kind of like a R6 objects, which is the type of a list. I assume for more complex usage, there are some advantages, but why I love to work with the SF object is mainly because it's a data frame. It's retaining. So once you pull this data, you can see it's a data frame, and the advantages of data frame are clear. It's easy to manipulate. You can apply any deep layer function if you want to subset or filter, and we see it in a second. It's straightforward as opposed to the SP object. So if you see the structure when you pull, we pull the countries level. So there is 177 observations, which each one represent a country. There are 64 variables, and those variables represent different names and codes that are used. So for example, you see here, this is the main name that you use for the countries, the abbreviation in 3 letters. There is different codes that are used or different standards, like there is the ISO 3000 something standard to country names. And this will come handy when you have some data and you're trying to merge it with this data, that you make sure that you are merging it the right way. So you need to figure out which one of those are related to the one that you are going to merge with. And as you can see, so there are 63 fields, and the 64, which was mentioned over here, is the geometric data. And you can, when you're using the head, you get some kind of like information about the boundaries of the data, the type of projection, and other information that, to be honest, I'm not sure what the other variables here is telling, but the projection is just multiple ways to project a map, and we see example how we can change it later on. So if you take this object that we just pulled and you just throw it to the base R plot, you can get those maps, and those maps doesn't really tell us anything. Essentially, what the default plot function will do is just will take in this object any variable that is numeric, and we plot it. So, for example, there is kind of like a label rank, which is I'm not sure even what it's representing, but you can see here that is you get this like label rank because it's numeric and it plotted, and all of those are just some type of codes. It doesn't mean anything because those are, it's not what we care, but to just show you that you just throw it over here, you can specify there is a, I will show it later on, how you can use the plot function to get a really cool plots. So if you really want to just get the data, just the geometric data to visualize it, so you are using the geometry. And the geometry is simply is a list for each country. There is a polygon with the country polygon, and this plot function and understand how to take all those polygons and connect them to one plot. So with that, we can start to talk about data manipulation, and this is where the SF object is really handy. So let's start with a very simple example. So now we plot again the same map, and let's say that we want to focus only on the countries that are populated, and we want to remove Antarctica. So to do this, you need to figure out which row represents Antarctica, and for this case, we will use the continent, and we will use dplyr and apply filter and say, I want everything in continent beside Antarctica, and we just plot it, and you see you get just the one that you the rest of the world without Antarctica. And this is what great about SF objects. I will repeat it probably multiple times, like working in the past with the other object, it was really painful to do filtering. And here it's just applying a dplyr that we all of us probably love to use, and you can apply any other filtering methods, not necessarily need to be dplyr, but it's a data frame, and the attributes of data frames are very useful in this case. You can also do subsetting. So say we want only the countries that are in Africa. So again, you apply a filter and you say, give me anything that has continent equal Africa, and you get this plot of all countries in Africa. And then there is another great function here, which is any states, which provide states level data. So for example, before we pull the country level, and in most states, they have different subsets, like in Nigeria it's the states, in the United States it's also states. In the states, you have the counties. So you have a hierarchy within the country, and sometimes you want to focus on that hierarchy rather, the country level. So in this case, we are saying we're using the NE states, and we say the country we want to pull is Nigeria, and we want to pull it in the SF object, and you can see object with 83 fields, and it is 37 rows. Each one represents a state. There is one that is general, but I think there are, you can correct me if I'm wrong, there are 36 states in Nigeria. And you can see here it's specified the type of each row is the state, and you have the state's name over here, and there are different codes that you can use depending on the abbreviation that different standards are using. So not necessarily that all states will carry, for example, all of those fields, but in most cases, so you see like this is the ISO standard. You will have it for any, typically it's for any states and region within it. So now, again, like we're taking the the base are plot function. We are just using the geometry of the object, no any numeric variables, but now we are just also saying, okay, just create a color palette. Those colors doesn't really mean anything. It's just to distinguish between each state. And we're also adding the longitude and latitude points and creating this plot. So this is, again, very useful when we are working in a sub-region or sub-country data. So now we will start to talk about the fun stuff. So far we saw the boundaries, but now we want to attach the data. And typically you will have some data sets, you have some labeling, and you want to merge it with this SF object. And we will start with the example of the COVID-19 cases. We will use for this case the coronavirus library. We'll pull the most recent data. We'll use the refresh coronavirus Johns Hopkins University function. And you will get this data set that is a daily summary of the total cases in each country. And it could be country and also could be sub-region. So just to back on, the coronavirus is a wrapper for the Johns Hopkins database for the tracking the coronavirus. So for example, for China, they provide the data on the state or province. For China, it's a province level. And in other cases, it's only at, for example, US, it's the country level. But we are interested now in the country level. We want to plot the cases across the world. And you can see that there is few location types. So you have like the location type is saying if it's a country or state or province, and you have the location code. And this is the location code type. In this case, it's the ISO 3166-2. Now, there are other information like what is the latitude and longitude point for each location. And there is either it's a death, new, meaning it's like for that day, how many people death cases were, or confirm and recovery. So for the purpose of this, we'll focus on new cases, or we will aggregate it to the total cases by country. So we take the data that we pulled before. We use the TidyR library. We just prepare the data move it from daily to a summary of overall cases, and we go by the location code, and date type. We will filter it before on the country. We don't want to have duplication. So for example, it could be that in some countries we will have both the state and the country. So we want just to focus on the country, and we will sum the total. And you can see that the output will get this table that you have the country name, the country code, total cases, and total death. Now, the next step, we want to merge this data with the object we pulled before at the beginning and call it world, which contain the polygons for each country, and attach it with the data. So first we will again filter Antarctica. We want to focus on only on populated area. So there are different variables in this data set that used to describe the country name, and we use the sovereign name for each state, and we also put the geometry with the polygons, and we'll do a left merge with this data frame. So at the end, you get a new data set. We call it World COVID-1. And this data set contains country code, the geometry, and the cases. And now again, we use the plot function to see what we got. And as you can see, here's a core plot with the scale of the number of cases. I think that it's probably got cutted so you don't see the scale below, but essentially you have here the different, you see Brazil is really high, India is really high, but also you see there are some countries that are missing. China is missing, Australia is missing, Canada is missing, US is missing. And one of the reasons that we have missing, especially US, is related to the fact that that for the US, there are multiple ways that you can write US. There is United States in some cases, and there is United States of America. So our left merge didn't work well. So what we can do is, we can use the IS2 code that we have on that we pull from our natural earth dataset, and use it together as left merge with this one, the location code, which is IS2, meaning that it's a abbreviation of two, or there is also three, but in this case we have two, so that's what we're going to use. And when we use this, you see that you also have the US, and US is where the highest cases, I think, in the world. So you see, like, this is why the color is now changed. This is the with the highest number of cases, the scale is changing. Then you have still India and Brazil with high, and then the rest of the world. We still have missing, like Canada is missing, and Australia. And the reason that Canada and Australia in this data set, and China as well, are on a state level or province level, so you don't have country level. But I think what the point here is that you need to make sure that when you are doing left merge, that your labels are matching. And when there are many countries that there are more than one way to write the country name or the country code, so you want to make sure that you standardize this naming and then do the merging. So let's go with the next example. This was a fun exercise. So I thought, like, how can we get something interesting in the state level in Nigeria? And I found this wiki page that has the list of Nigerian states by population, which has one table. It's coming from the National Bureau of Statistics of Nigeria, and it's the rank in terms of population, the state name, what was the population in 2006, and what was the population in 2016. And I said, okay, let's pull this data and let's plot it. So if you don't have experience with pulling, extracting wiki pages, so I use Harvest package, which is a great package to pull data from Wikipedia. And if you're not familiar, you can just copy this code, and it should still work for you as long as you have the underlying packages. And essentially what it does, you're providing some URL. It's read the page content, and you are parsing out of this page if there are any tables. So we store it in the tables, and then converting it into from HTML table to data frame with the HTML table, and selecting the names that I want to use. Once I pull this, I'm doing some reformatting. So the first thing is that the data is coming as there is separation between the numbers, so I want to remove those. So I'm using some regular expression to clean the data and convert it into numeric. And also, one of the things that in this data, I'm not sure, yes, you can see that it's states. So each state there is, canoe state, and technically it's redundant. We don't need the state, so I'm also removing the states out of it. And eventually I'm getting this table. I also created a state fix. And the reason that when I first tried to merge it, I saw that there is one state, the naming in Wikipedia is a bit different in the way that they spell it, as opposed to our natural earth. So I also did a fix for this, and I changed the name, the spelling as it is in our natural earth, so it won't have the missing value. So once we prepare the data, and again, we want to have one row per state. I'm doing a left join with the data sets that we pulled before with the geometric data. So Nigeria is the data set that we pulled before with from our natural earth with the geometric data. We're doing a left join, and we get one data set with both the population data, I call it Nigeria pop, and the geometric data. So now again, I'm using the plot function. It's nice that you have you can use like PESAR out of the box and do the work, and you get this plot that you can get, see where it's the most popular states, and you have Lagos, which is the second one, but then Kabul, I hope I pronounced it correctly, is the main country, and you see like the difference is very clear. So maybe I will pause here and see if there are any questions before we move to choropleth map.
A quick question. Hi, Rami.
Hey.
But are you planning also to expanding those workshops to other packages in the future and talk about other things like time series or something that is not strictly related to the map? Just out of curiosity.
If you want to do a workshop of a time series, I'm always happy to do a time series. Time series is my, my main passion is time series. So we can.
Hello, Cielo.
Okay.
Hello. Hello, Cielo. Please, can we, Remy, excuse me, please. Please, can we leave the questions after we have Q&A session where everybody can ask his question, please?
Yeah, sure.
Yeah, please. Thank you.
Okay.
Cool.
All right, so let's move to the next topic, which is, we worked on the data. We saw we're pulling the data. We saw how we can merge the geometric data with actual numeric data. And now we want to visualize it beyond the base R that we saw before. So the first one is the map view. And the reason that I didn't include more about the map view is the reason this type of R Markdown format, so I need to squeeze it a little bit, and the code is disappear. So maybe I will just jump to the vignette that I created. But essentially, map view is as simple. You're throwing SF object. You're saying what is the color that you want with the numeric value, and it will do the rest. So you're getting interactive visualization. It is a leaflet JavaScript, but the wrapper is the map view. And it's like a really amazing package. I recommend to check their documentation. You can do much more than just plot, the polygons. You can add more information, labelings, and so on. But this is, I think, much. I always prefer interactive visualization than static. And this is a simple way to do it. And you can see like you can play and can add more information if you have multiple numeric values. So you can include all this in this map. I think you can change the schema. And again, we use population. You can have multiple variables. So like, let's say if we had, maybe the other information like income, GDP or anything, you can also add multiple variables and, say I want other variables to view. Unfortunately, it's not really rendering well on this type of slide. So I can show more example. Maybe you can quickly go to this vignette. And I can also throw it in the chat. Let's go. Yeah, so again, you see, once you create the object, it is straightforward to use the map view. You just define the numeric one that you plot. In this case, we are plotting, this is from the coronavirus, you're plotting the percentage of vaccinated people per country. And then you see this is the best one. You can, it just use the variables that you use, but if you want to modify it and create packets, you can define those packets of the color scale. You can modify the titles. Again, you see, for example, by default, it will use gray color for missing values, or you can also, again, filter it. You define different palettes using the plasma from the Verdis package. And essentially, again, like it's interactive, you can go, you see there is more information here. And so that you can edit and play with it. So I recommend, this is probably my first package that I will go to plot, depending on the needs. It's really nice and easy to use. So with that, let's move to the next one, the Themap. Themap is Thematic Maps. It's another great package. By default, it's not interactive, but there is options to get the same interactivity that we saw before.
Hello. Hello, Rami.
Yes.
Okay, so based on, sorry to cut you off, based on request here, we would like to take some questions now, because I think there are people who want to ask some questions. So I hope that will be okay with you.
Yeah, whatever
okay,
works
so
for you.
Okay, so I'll call on Abubakar now to take the questions, and whoever asks the questions, Abubakar will moderate now. Thank you.
Sure.
So if you have questions now, you can, okay, I think we have, okay. Abubakar, are you there?
Maybe I can go to the chat.
Okay, okay, there's somebody raising up his hands here. Oluwafemi Oye, please, do you want to speak or you want to write your question? You can go ahead now.
Okay, thank you very much, ma. Also, Mr. Krispin, I think thank you very much for this great workshop for today. Like on my own end, my question is that because I am really familiar with the leaflet, though I've not been using
I'm sorry, you're being cut at this in my end.
I've seen a lot from your presentation, but
I'm
question I want to ask, working with the
I cannot hear the question. I'm not sure if the internet on my end or on your end. Maybe is there? We can do it in the chat, maybe. Okay, so it's not only my end. So let me try to go over the questions over here. Does the title and color font size in which package or which in the plot? I'm referring to these questions. How do I change the title, color, and font size in R? So each package would have some application that you can define, and I can show an example in a second about how you defining those things. Like ggplot is probably the most advanced, but also other packages has this functionality.
Hello, Remy. Please let me break the ice from here. I can see everybody. We have participants who want to ask questions. Yes. Please, can I go ahead and accept questions with your permission?
Yeah.
All right. Ladies and gentlemen, we will just break for the next 5 minutes so we can have questions. Anyone with question, we can go ahead and ask this question.
Okay, sorry, I think there are questions in the chat box now, which you can.
Okay, let me look at it. I can't see anyone. I have from Oluwafemi Oyedele, he said, can I add my coordinates to the SF object? Remy, there's a question.
Yeah, so to add coordinate, technically, you can create your own SF object. Like let's say that you have your own polygon, and you say there is a functionality in SF that you can take a polygon, which is just a list of numbers, and say make it as SF object. Definitely you can if you have your own, and you can create your own SF object. It's like as data frame, like when you have like some metrics and you want to convert it into data frame, so there is the same functionality. I never try to do it. It's always the case that it's easy to pull the data that is already someone did it. I guess there are some cases like one different level, let's say below the state, that might not available there. So there might be other sources, so you can convert it definitely.
Thank you very much. I have another one from Ahmed. Ahmed says, our graphics engine version 14 is not supported by this version of RStudio. The plot tab will be disabled until a newer version of RStudio is installed. Try to install. Okay, I think it's a contribution. I have another question on how do I change from Narendra Kumar, who says, my question is, how do I change the title color and font size in R bracket ggplot2?
I have an example later that we can go over it with ggplot and about the fonts. I would say that it's just like it's a argument that you need to say what is the size that you want to use.
Okay. Please, if I don't go through your questions, it's just that I log out and I came back and I can't see questions. Please, can you repost it before we move on? I have from Toyin Ola, who says, what will be the easiest way to create custom geographics, e.g. aggregating US countries to create regions within a state?
So US is the, it's a bit different. US, you have, we can actually try it later, but US, you have like, you have the US country, and then you have the states, and you have the counties. Are different codes. Like in the US, they use non-standard codes that are unique for the US. There is the FIPS or FLIPS, I forgot what is the initials, but it's something like this. And there's the zip code. I'm sure the SF package as application that you can work in those levels. I'm not sure if, I'm also sure also if you pull a natural earth, you can get into the county level. If not, there are plenty of other sources that you can pull it. There is the Geographic Bureau, I forgot the name, but the US Geographic Bureau that provide us as a shapefile. Shapefile is a different format for, it's like a non-R format that you can also read it into R and convert into SF object.
Okay. And Piparu, who says, can we have an example of HTML inside a tooltip in the map?
I can show it over here. Like this is the map view. It's not really rendering well inside the slides, but that's the file, like the tooltip that I got with the map view. I know that you can create a more custom with leaflet, with the leaflet package, but I think leaflet package, I'm not sure if the leaflet package is working with SF object. So there is, I don't remember why I went to work, like I started to work, I converged into map view, but I think that it was easy because it was supporting SF objects, which I'm not sure if the leaflet, I might be wrong on this, but I know that the leaflet has more options.
Can you put also plots inside the tooltip?
I'm not familiar with these options. I know that you can, there is other functionality that you can add with the Tmap. I didn't present today, that you can add like distributions, like that you look at this, you have like this view on the map, and on the side you can add distributions, but I'm not familiar with more options. I know that there is another, Plotly has this functionality that you can customize your tooltip, by far better than any other package. The thing is like that Plotly, it's harder to plot data. It's require much more effort.
Right, thank you everyone for now. And I think Rami, you can proceed with your presentation. Later we can have 1 or 2 questions again.
Yeah, so we're going to talk about the Tmap and the ggplot, and then we can go over to questions if there are any other. All right, so let's go back to the Tmap. Tmap is a wrapper for, I think if I'm not mistaken, it's a wrapper for the ggplot. It's using under the hood some functionality from the ggplot, if I'm not mistaken. But it's supporting the SF object. It is very straightforward to work with. And in this case, we will show how to plot the COVID-19 vaccine data from the coronavirus. So one thing that, and again, it's going back, at the beginning, where how how I started to discuss with Likisha, I will pronounce it correctly, about she sent she opened issue about my vignette from the coronavirus that she could not this means she cannot render it on her end, and it was after we discussed on a GitHub issue, we found out that we're using different versions of packages, and there was recent update in the SF package that changed the default, which caused some error. So that's why we added this option. There are some polygons that are different format, and I'm not going to details. If you want, I can share the link from the GitHub issue, but in order to be able to work, I set the SF use S2 as false. So it's just spherical geometry switch off. Oops. So again, let's go back to the vaccine data. We're pulling the vaccine data, and again, you can see that. I'm sorry, this is the first time that I'm using this format, and some of it was guided. I need to work on my CSS skills to improve it for the next talk, but you can see that again, like you're getting the fields are, you get some country, you get a date, it's a time series, you get some number of doors, the number of people that fully vaccinated, and we're going to use these variables to plot the people that are fully vaccinated by country. And you see there are different codes. So there is ISO2, which is IS code with abbreviation of 2 letters, and there is ISO3. And there are other UIID, which is, I think, ID used by the United Nations. And we use one of those to do the merge with the geometric. So we're creating the map objects. We're pulling all the countries. We are selecting IS2. This is the one that we want to use to merge with this one. And we are also using the geometry data. And then we are running the same left join ways we do the map data, and left join with the external data that we want to add to the SF object, not the opposite around, because we want to merge it with the SF object and not merge the SF object to the data frame, because you're losing the attributes. Once we pull the data, we do the left join, we calculate what was the percentage of fully vaccinated out of the population of region, and we are merging it by the those 2 codes, the ISO2 and ISO3. And again, we're removing the unpopulated area. And if you can see, the syntax is really similar to ggplot. So defining the shape object, which is df1, it's a SF object. And then the TM polygons is the function that you use to define the data. So you have the column, so we want to plot the percentage. You want to define the color scale into 8 buckets. Like here is defining the bucket, so we define it as 8 buckets. The title and the palette. We're going to use the blue palette. And you see here's the title that we use. It creates 8 buckets. And the gray one is the missing. So this is a very simplistic way to create a plot with the tmap. Now let's add some more functionality. So we talked at the beginning about the projection, and the projection is the way that you are, when you take a, the map is the geometric is on assumption is that is on is a rounded, right? And we are flattening it. So the way that you're flattening planet Earth is there are different ways to do it and different type of projection. So now I'm not sure what was the default. I think the default is 4,000 something. I just use, for the sake of showing the example, a different projection, and this is the different standard to project maps of Earth. And so it's again the same plot, but a different projection. You don't see much of difference, but there are some cases that you will see that a significant difference, mainly if you're looking at the country level. Now we can, customize more the plot and add some, define the colors better and titles. So in this case, we will just focus on South America. So we take the original object, we are filtering countries in South America. And again, we use the same structure, and we get this plot. The nice thing about this function is it automatically places the legend where you don't have data, and you can also customize it. So now let's do more customization of the color and the background. So the TMap packages different styling you can just use out of the box. And in this case, again, we're starting with the same plot as before, but we add styling and we use the cobalt style. We also adding some labels. And here there was a question before about how you define size. So here, in this case, you're defining the size of the text. And we're also defining layout. So this is the title. And this is how we define the position and how we define the margins. And I think this is a bit nicer view of the map that we showed before. You add, you can see like that you have now title, where the name of the countries using the three, you use the ISO 3, the 3 letters abbreviation of each country. And the background is dark blue. Last but not least, before we will move to the next topic, the Tmap enable you to create a map with a leaflet, like the map view, in order to use to create interactive. What you need to do is to set the Tmap mode to view. The default is plot, and you just repeat the same plot. Unfortunately, it's not really rendering well, but if you do it in a normal outside the slides, it will show this directly. And let's keep moving. And again, you can hover and get for each country the percentage. I'm sure you can, if you probably, you can customize the tooltip with JavaScript if you have some background in JavaScript. So let's go back to the Nigeria population, and let's replot it with the Tmap. So we're going to return to non-interactive. So we change the mode to plot, and let's create the object. So we start again. This is the object that we created before with the geometric data when we merge with the population of the states. We add the polygons. So the column that we're going to use is population 2006. The style, so style is defining if it's a continuous or discrete data set. So in this case, this is continuous. So it's ordered. You may, by default, like before we use the N to define buckets. In this case, it makes more sense to use order rather than buckets. We're going to add some title, define it as palette as blue. We add the same style as we use for the South America map, and add some subtitle. So this is where I define like where we use the data from, and the layout, which is the title defining the margin of the plot. And that's the output. Maybe should increase the margin because it's like there is overlapping, but essentially you can control it with the argument. And you see this is not categorical, but ordered and continuous order. So again, like this is really great function. It's more relevant than non-interactive. It's easy to create and customize maps. The question is like, if you want to do interactive, I would probably go to map view or leaflet. But if you want to have non-interactive, this would be probably my first choice. So now we can move. Okay, yeah, forgot this functionality. This is another cool functionality this package provides, which you can facet. Similar to the Gplot facet, you can say, I want to facet by the polygons. In this case, when you're talking about the Nigeria population, it's to facet the plot by the states. So we are doing the same thing, and we just add the TM facet. You can say how many, what is the limit of the number of plots that you want to show in one plot. Let's say that if you have something really big, you don't want to blow up your plot with too much data. In this case, we set it to 13, and you get this. So now it's essentially take all the different polygons and making them as a separate plots, and you get the. I think what you're losing is the size might not be on the same scale. It might be misleading, but you still get the magnitude, which you say the canoe is the biggest state. And after this, there is Lagos. It used this. Maybe we should set it as because I set it into categorical, but maybe it will also make sense to use it order. So this is a really nice funky under the hood that you get it really fast without need to add additional coding, which you probably need to do it if you're doing it manually. So last but not least, the Gplot2, one of the main engine now for visualization. I would say that there is probably much more amazing stuff doing in Gplot2. I'm showing you just an example. The Geom SF, which was designed to, as the name implies, for working with SF objects. But you probably, I see what there is now in Twitter, the 30 days maps. It was throughout November. There are a couple of more days left. If you go and look for the 30 days map challenge hashtag, you can see what people are doing with Gplot for maps. It's really amazing. It's really beyond the scope of this discussion. I'm probably not in the same level. So for this one, we're going to use again Gplot2, Verdis for the color palettes, and essentially this is like normal Gplot syntax where we're defining the data set and the variables, and here we are adding. We're saying this is SF object, so treat it as map. And we are defining which color palette to use. There are some built-in color palettes. We use the Verdis P. And you get this map. And if you can see, it's a very Gplot basic plot with the gray background. By default, it's put the longitude and latitude points as the Y and X axis, and it's by, I would say it's like it's not really continuous. It's by some buckets, and we can add more customization. You can really customize the color scale. You can customize, again, for the questions about the text, you can really set this size of font and add some labels. So we're using the labels and we are adding here for each state, like we did before, we're adding the state name. Oh, and we add the theme void, which is just give me a white background without the gray one default. And you get this here now, the scale is continuous. It's a bit, I would probably would be, it's too much dense, like the title might be, the labels are too dense in this type of plot, but again, just show you what you can do with the ggplot here. I would say probably like you can, from all the packages that show the more advanced features that you can probably get is with the ggplot2. You have higher customization, but it requires more effort and knowledge. So with that, I just before we can go to the Q&A, I added all over here some resources. There are some books that I typically am using to pull data. Some books that you can use, they are open, they are free. You can, go over they're really explaining well how to work with different beyond the SF object. And they have a great example about geospatial analysis. Here is the link for the packages that I showed over here. SF, our natural alert, MapView, TMap, and ggplot, the SF extension. Also, a link to some of the examples that I showed here from the coronavirus. There is example for COVID-19 San Francisco package and Italy. And yeah, that's all what I have for today. Now we can go for questions if there are any.
Thank you very much, Rami. Amazing presentation. And I would like to say this, Rami, when you say Lagos, I don't know if people who are from Lagos, if they heard you, I'm going to sue you that you don't call Lagos, you call it Lagos. Yeah. All right, thank you very much. Yeah. Please, any question? Let's go back to our chat and start rolling out the questions. I think we have a question from Piparo, Teolo Piparo. I found this package for this interesting. No, he was given, that is a link. We customize, we have Olufemi said, can we customize the plot's background on Tmap?
Oh yeah. Yeah, so this is essentially you have the TM style, but I think you can also do it yourself. So if we can actually go to the.
Okay. Next question. Still waiting for question to roll out.
So yeah, there is examples over here on the. If you go to get started. Yeah, so you see here there are layout, and you see here you can say background color and define what is the background color. So anything can be done. There are the default options, and you can customize by yourself.
So and I have a question from Ahmed Olaruwaju, who says, awesome presentation. So even without ArcGIS software, R is really great for geospatial analysis.
Yes, you can do a lot. Obviously, there are some limitations, but like again, for depending on the use case. For me, the reason that I started to do those maps was I wanted to create vignettes for the packages that I created for the COVID. It would make it made sense to me to plot those. It's a country level to plot it with maps. So this is where I started to explore it and learn it. If you really want to do, there are some much more complex stuff that might not be the best tool, but still, if you go and see, for example, this is amazing. I saw it yesterday, was like blowing my mind. You go to map view, I think it was map view. And you see the number of downloads. It's like 20,000 per month, overall 1 million. So it's really popular, and again, this one 25,000 for our package, 25,000 per month. I think it's a lot. It means a lot of people are using it.
And I have a question from Abraham, who says, will you choose T-map over leaflets? Can this be combined with Shiny, with R Shiny?
So I would say that depending on the use case, if I would use Shiny, so map view or leaflet would be my first choices. Map view, I think there is somewhere somewhere it's probably hiding it somewhere. There is like example how to embed it with Shiny. I'm not sure, but there is some example I think that you can go and see how to embed it in Shiny. If it's like PDF, so I would say the downside of the leaflet based packages like leaflet R or map view, that it's very hard to customize the titles. You cannot have titles. You can add titles to the legend, but it's sometimes like you want to have title if it's not interactive, and this is where the ggplot and the something like Tmap or SF much more handy than the interactive. So again, depending on the use case, if it's Shiny, so then definitely either map view or leaflet R. I think there is this one also. So this is like, you can see, the SF object, there is almost 2 million download per month. This is like huge for any R package. I don't know how many packages you have like this amount of people downloading per month. So I think there is like really big community in R that's really doing GIS analysis. And it's really, for some use cases, it's a great use case. I think there are other use cases that we didn't discuss here, like roster data, 3D, that I know that there is like I think it's a ray shade library that you can do all stuff, but this is where I would say that other tools might be much more sufficient than now, but still I can do it. So depending on the use case.
Okay, I think Abubakar is off now. So there's another question here. Thank you. Okay, that's from Toyin Ola. Thank you for taking the time to share your knowledge, Rami. I have experience with manipulating shape files in QGIS and Tableau, but I'm on a quest to learn how to make maps programmatically in R to make the work more producible. This was you. So that was the comment from Tony Nola. Thank you so much. Thank you.
You're welcome.
Do we have any other questions in the house? And okay. Okay. I think it's a big thank you from everyone here. We're getting a lot of thank you from the participants. So that was really okay. Do you have any other thing you want to add for us, Rami?
I would say, go explore. There are so many resources that you actually maybe share another link in the chat. Let's go here. Get so many windows opened. So if you don't know the big book of R, you should check it. Me just how do I do? Trying to put it for everyone. Oh,
Okay.
What I want to show you, there is so that this book is organized that it's by topic. So you have here, big data, book down, block down, data science, and you have also GIS, and it's pretty much a lot of geospatial. So I would recommend to check most of those resources are free and open. This is really great book. I use it a lot, which kind of like go over the foundation. So if you're really interested, I would highly recommend to go and try to explore those books. They're giving a lot of information, and they are, for free. Use them, leverage them. This is where I would start. This is where, when I get stuck, I would typically go to those resources.
Okay. Thank you so much. Okay, we're getting a lot of thank you here.
You're welcome.
Comments. Thank you so much. Okay, good. And that's good. That's a good comment for Google as well. Okay. Thank you for adding it to your Google. Thank you so much, everyone, for joining us tonight. And I will really want to start. I'm really grateful. I'm so grateful. I don't know how to express it, but I'm really grateful. Thank you so much. You've been a wonderful teacher, and I'm looking forward to learning so much from you. So just watch out. I'll be popping in questions anytime I have it. So thank you so much. I really appreciate you. Thank you. So thank you everybody for attending the webinar tonight. So okay, Theo is still requesting for the time series. I think we'll look forward to getting you back on the webinar for you to take that one. Yeah. So
time series is my it's my favorite area. So
okay,
you don't need to convince me.
Okay. Yeah. So we're rounding up this year with your webinar, and it was a really good way to end the year. And I'm really grateful for that. Thank you so much. We're really grateful. We're grateful. And to everybody that took time to attend the webinar, it's late, it's getting late here. And today is always the weekend. It's really difficult to tie people down, but I'm really appreciative of the value everybody derived from the topic we took for this webinar. And I know everybody from the comments here they really gained a lot from it. So thank you so much. Thank you so much, everybody. Thank you. So on this note, we're going to close for today, and we look forward to having you next year, 2022. By God's grace, we look forward to having a wonderful time together again. Thank you, everybody. So that will be a bye-bye from me here. Thank you.
Thank you all, and thank you for the invite.
Mhm.